What I'm here today to talk about is some of the stuff that we think about, keeps us up at night, so that you don't have to. And that is, for today, in the area of standards. So how standards are evolving and how those standards play in a Dante world where we're bringing those things into products so that they can solve problems for you. So hopefully the clicker works. There we go. So standards is one of my favourite topics. I like this slide because it kind of says what needs to be said about standards. There's like really good because there's so many of them. On the right here, I love this graphic because it's a common thing. There's a common theme in standards bodies where they say, "Oh, we've got to do something to solve the fact we've got so many different standards. Let's write another one." Yeah. Okay. Anyway, so they move on. So today's landscape for AV over IP is evolving. It's complex. The standards bodies are complex. There are people who write documents. There are people who write roadmaps. There are people who write, protocols. There's all sorts of stuff going on. And this is a picture that I put together and update. And I had to update it before this week because it had changed since the last time I gave it a few months ago. This is an eye chart. The point is not for you to go through and look at everyone that's on that list, just to know there's a long list. And that we think about it and we spend all of our time trying to work out how these things play and what we need to include in our products so that you know that you're going to have a solution that's going to work when you go to plug it in. And so this is where we talk about the difference between a standard and an implementation or a solution. Okay, so technical standards are essential. You can't have a network without a standard. You can't build networks without standards. I'll repeat that because it's so important. So things like DNS, DHCP, that sort of alphabet soup that's in there, they're crucial. You cannot build a network without those things. And Dante includes all of them. They're in every Dante endpoint. It wouldn't work without it. For those standards to actually be successful and useful, all right, they have to actually solve a problem. And all of those standards that are up there do. They solve real problems. And the point of implementing them is to solve that problem and then create some kind of economic utility. So, you make money out of it. All right. There's no point doing something for no reason, and the most often quoted reason for doing anything is to make money. That's why we're all here. The standard needs to play a role as part of a system, so it needs to fit. It needs to have a spot in the architecture, and it has to be sufficiently narrow to actually kind of so that everyone can agree on what it needs to do. If you try and paint a big picture, a Michelangelo picture of the ceiling, you're not going to succeed. So narrow your scope as well. So having said all that, the best way to view Dante is not as a standard, because it's not, even though it's a de facto like standard. People use the word de facto standard to describe Dante, but it's not a standard in the technical standard context, and it's not a protocol either. It's a solution. Okay, it's a building block. It's a software stack. It's a stack of stuff that you can use to build networks that solve real-world problems. We get asked a lot about AES-67, what it is it going to replace Dante? So I thought I'd address that as well. AES-67 is actually quite a sensible standard. Oop, went backwards. It's inspired by Dante. It takes pieces of what's in Dante and Ravenna and QLAN and other AV over IP solutions, and defines how to actually make that audio traverse through the network. It's deployable on standard networks, so unlike AVB in the past, where you had to have switch infrastructure that supported it, you can deploy AES-67 connections on standard networks. But it's very, very limited in scope. It's designed for interconnecting two systems together, not to become the basis of a complete system. So you wouldn't build an AES-67 system in the way that you would a Dante system and expect it to just work. It covers really only two components of a solution, and that is the sync component and then the transport component, the boring details of putting audio in packets and sending them to somebody else. There's no information about how you do discovery, stream setup, device management, any of the stuff that you get in a solution. It has been picked up by the broadcast industry now as part of the SMPTE standard suite. Okay, so that's a place where it has actually gained some traction. So to talk about the interconnect component, I've got an example here where we have a Dante system on the left, stadium that you are probably running Dante for all the live production and the sound reinforcement in the bowl. And then in the broadcast truck out the front, they may well have a Lavo console and a Ravenna system. So how do you get audio between them? Well, that's a place where AES67 is useful. It's kind of like a big long networked MADI cable. That's essentially what it is. You plug it in at this side to the right plug, and you plug it in on this side to the right plug, and then hopefully the right audio is coming down out of that connector and going into that one. But that's kind of what it does. So here's another graphic of the same thing, where we're doing exactly the same thing with SMPTE 2110. Okay, so think of it in this way. It's an interconnect between systems. The best way to describe what I just said visually is to think of Dante as a technology stack, or we talk about it as a software stack, but a technology stack. So a stack of things that we put together that solve problems, that create a solution. And so this is the sort of a recent picture of our Dante technology stack. And if you start at the bottom, you can sort of look through that and you see, okay, so there's networking connectivity, there's physical connectivity in the networking. So we do gigabit solutions, we do 100 meg solutions, we allow people to connect over fiber, we allow people to connect over copper, etc. We use some of the features that are in the network, you know, QoS, that was inspired by voice over IP, that's why it works. We use protocols for clock synchronization, so that's in there. Transport for the audio, we've got an RTP-based solution for doing that. But then on top of that, we keep adding features, things that actually solve problems. So label-based routing, the ability to give a device a name and then find it by that name and then say, you know, mixer, I want you to send your audio to amplifier. Really, really simple, but that actually is based on a whole bunch of technology. The fact that the device, when you plug it in, automatically configures itself. You know, if there's a DHCP server, I'll use that. If there is no DHCP server, I'll use Link Local, and you can also configure me manually. And as you build up these things, you start to build up a full stack of components. So, you know, simple routing, managing latency, monitoring that network, performance monitoring, glitch-free redundancy is a big one. I know a lot of people were very nervous about using IP networks early on for critical audio. So redundancy is a great way to ease that pain. The reality is you probably don't need it, but it's there to make you feel better. And yeah, we keep adding to this stack every time. So just this week, you know, we've added more implementation types to the mix. So we've added the software stack, we've added the video transport as well. So we keep growing this stack. This stack keeps getting taller and taller and taller, and will continue to get taller as long as Audinate's in business. If you were to sort of come back and look at where AES67 plays and what it does, well, it kind of touches these 2 or 3 little bits. So it's just a small component. And then if we're looking at the way that SMPTE is trying to cover this for the broadcast market, a very vertically, you know, application-specific solution, it touches a couple more parts, but it's still nowhere near what you need for a full solution. I think I might finish here, because I think it's a good spot to finish. The thing I want to leave you with is just bear in mind that my guys, my team, we think about this all the time. We're trying to design Dante so that it takes advantage of all the standards it needs to take advantage of to give you solutions that actually solve problems for you. So if you want to have a chat afterwards, I'll be on the booth today. I'm happy to have a chat with anyone who's got any questions about any of this stuff. It can get pretty boring. I can see a few eyes, people falling asleep. So thank you, and yeah, hope you have a good show.